So hi everyone, then we continue for this example for more difficult questions. So find the inverse of each of the following function. For the first function is a surd function. To find inverse, we use composite method. So when you want to find f inverse, means we will start with f inverse equals to x. So substitute our f inverse into the x. So x will be replaced by this f inverse. Then we will get square root of f inverse minus 2 plus 7 equals to x. So what we need to do is clear off this operation here to get f inverse. So we move the 7 to the right hand side. It becomes minus. Then we move the square root. So when we want to remove the square root, we're going to square both sides. So you can see we have one surd here. So we square both sides. Then square root and square can be simplified. Therefore, we will get f inverse x minus 2 equals to x minus 7 squared. Lastly, f inverse equals to x minus 7 squared and plus 2. So our quadratic in the completing the square form, then this answer will be alright. Then we continue for question B. So find this f inverse. We will start with f inverse equals to x. Substitute this f inverse into the x here. We will get f inverse over 4 equals to x. So find out our f inverse, we get 4x. So that's all. Then we proceed for C. So still using the same notation, which is function of x. Then to find its f inverse, so f inverse equals to x. Substitute f inverse into x here, into our function. Therefore, we will get f inverse square minus 1 equals to x. So simplify this, f inverse square equals to x plus 1. Then f inverse, when I want to move our square to the right hand side, actually we are solving quadratic. So we will have two answers, maybe positive, maybe negative for the square root of x plus 1. Then notice here, we have x more than equals 0, means our answer always positive. So as you see it, quadratic never to be one-to-one function. But after it define its domain one part only, taking the positive side only, so this function can be inverse. Therefore, this function can be finding its f inverse. So when you're finding that f inverse, we get two answers, so that is not logic. Suppose the function one-to-one, we're supposed to get one answer only. So from here, since the domain given is positive, means our answer here, f inverse, answer only involve positive answer. So this is the quadratic side, we taking the positive side to be inverse, therefore our answer will get the positive answer. This is our f inverse. Then we continue for D, where our function is gx, which is x squared plus 2x plus 6, where you can see this function also stating the domain for x less than 0, so that this quadratic function can be inverse. So as we can see, this function of gx is a quadratic function. To find its f inverse, it will be better for us to completing the square first, so that we can find the x easily, or we can find the f inverse easily. So for this gx, completing the square, put the x into the square, then for the value b, we're going to divide by 2, so positive 1. So immediately minus that 1 square. The value of c, we just copy. So it will be x plus 1 square plus 5. So to find G inverse, so just now our function is fx. So to find f inverse, f inverse equals to x. So to find G inverse, it will be G composite with its inverse. We're getting x. Therefore, we're going to substitute this G inverse into the function of G. So substitute this G inverse into the function of G. X here will be replaced by G inverse. So we will get in the bracket G inverse plus 1 square plus 5 equals to x. So for here, we simplify. Move the 5 to the right hand side, it will be minus 5. Continue. We want to remove the square to the right hand side. So G inverse plus 1. When we move the square quadratic, we have two answers, positive and negative. And when we're doing inverse, impossible, we get two answers. So we only have one answer since this function 1 to 1. Then we refer to the domain that gives us. So the domain gives us since x is less than 0. X is less than 0 means this is 1 to find the negative answer. The negative part of the function to be inverse. So therefore, our inverse result should give us negative answer. So finally, simplify this. Move the 1 back to the right hand side. It will be minus 1.